Hey guys, what's up? So today I'm just gonna explain a lot of rules like sine of a plus b, tan of a plus b, cos of a plus b, log of a plus b, log of a to the power of b, e to the x, d of whatever. Let's just do it as we go, right? So let's start with one of the simplest ones. I think at least sine of a plus b. It just uses a little bit of geometry, right? So here are your angles. So we have two different demonstrations. Let's just draw these. So here's A and here's B, okay? So, we want this height right here, right? And the height would just be this height plus whatever this height is, right? Well, we know that this height is sine of A multiplied by cos of B, right? Because we're assuming that this is 1. So the length of this is 1, but the length of this is not known, right? So we have sine of A multiplied by cos of B, its hypotenuse, plus this angle right here. Well, this angle right here, alpha, marked over here, I did that circle really bad, okay, as marked as alpha, let's try to calculate that, okay? So, if this is A, then this part right here must be 180 subtracted by A subtracted by 90. So I believe 90 subtracted by A, right? So this part is 90 subtracted by A, and then that means this part is also 90 subtracted by A. Well, you have a 90-degree angle here, so let's just use some math to calculate that angle, right? So we'll say alpha is equal to, first we'll do 90 subtracted by A, 90 subtracted by 180 subtracted by A subtracted, yeah, okay. Add 90 to that, and 180 subtracted by that. So now we have alpha is equal to 180 subtracted by 90 subtracted by 90 plus A. And that means 180 subtracted by 180 is 0. That means alpha is equal to A. So now we know that that angle right there is equal to A. Well, this length here to here is the cos of that angle multiplied by its hypotenuse, and its hypotenuse is sine of B. That means that this remaining height must be cos of A multiplied by sine of B. Okay, so we already got the first one out, and when you do sine of A subtract sine of B, it's literally just I'm pretty sure you guys will be able to figure it out with a little bit of algebra. It's about the same process, right? You literally just calculate this height and then this height and subtract this height by that height, or something like that, yeah. Okay, so now what we'll do is cos of the angle, right? So I'll do my best at drawing this, and I'll try making it a little bit bigger so that you guys can see even better. Actually, you know what? I'll try explaining the sine of A subtract sine of B part, right? Very quickly. Okay, so you have this height, right? And you have this height. What you want to do is you want to calculate the angle, right? So if B was to protrude into A, right, there would be this angle like that, right? What you can do is instead of doing a lot of complex math, you can simply take this height and subtract it by that height, right? So this height is going to be equal to that part, this and this will pretty much be the same, something like that, and then you'll get your measurement pretty much. So then you just switch this to a subtraction sign. Okay, that didn't require that much math, so that's good. Let me see if you guys can see that. Let's move it up a little. Okay, so now we want the cos of the angles, right? Well, when we want the cos, right, we can calculate this total length and subtract it by this length right there, right? Well, yeah, so what is the length of that part? Well, the length of that part is cos of A times its hypotenuse, which is cos of B, subtracted by cos of this new angle, okay? Well, you know what? Instead of subtracting it by this part, let's subtract it by this part. That's what I meant. I didn't mean to subtract it by that part, right? So we'll just cross that out some way, okay? So we'll make this new line, okay? And we already before realized, calculated that this angle is A. That means that this part right here must be the sine of A times its hypotenuse. Therefore, subtracted by sine of A times its hypotenuse, which is sine of B. And there you go. That's the formula, okay? Now let's do another one, which is tan of A plus B, okay? The way we can do that is by realizing that tan is equal to sine of A over sine of B, right? Not sine of B, I mean cos of B. And this is true because these ratios explain the height and such of like the triangles, right? So you would say that this is sine of A and this is cos of B. And since tan is this angle over this angle, sine of A over cos of B will always be the exact same, even without doing that, right? So you can do, actually, you know what? Let me just prove it mathematically. So we'll multiply by its hypotenuse, which is, we'll call C, over cos of B, multiplied by its hypotenuse, which is C. They cancel out and you get sine of A over cos of B. Okay, so we'll just...
বাবা উঠলো কখন?
আব্বু আমি একটা ভিডিও করতেছি।
কথা বলবো না তো?
হ্যাঁ না, আমি এটা রিমুভ করতে চেষ্টা করব না এই পার্ট।
আচ্ছা আচ্ছা, আমি জানি না তো, আমি তো ঘুমাচ্ছিস কখন উঠে গেছেন?
হ্যাঁ অনেক
যে আছে যে পাপাই আছে তোমার বড় মামা, এটা আছে খেয়ে এসো।
ওকে খাই বলে আমার খিদা নাই, আমার ঘুমাইতে
একটু আসলে নষ্ট হয়ে যাবে, ওই যে ঠান্ডা গেছে, একটু খাই এসে তারপরে করে দিন না।
ওকে হ্যাঁ খাইতেছি পরে। Okay, let's let's get back to this. So we know that tan of A plus B must be equal to sine of A plus B over cos of A plus B. So we can say tan of A plus B must be equal to sine of A plus B over cos of A plus B. Okay, and we'll use this formula to expand that part out, and we can say that that's equal to sine of A multiplied by cos of B plus sine of B multiplied by cos of A. Can you guys see that? I hope it's not too down. Oh, it's in an angle. I see. Okay. Let's start moving it upwards a little. Okay. So we have that, and its denominator will be cos of A plus B, which is, as we calculated, cos of A multiplied by cos of B subtracted by sine of A multiplied by sine of B. And what we can do is, let's just start multiplying it by numbers that are going to equal to 1, right? So we'll rewrite it right here. Sine of A multiplied by cos of B. I'm holding my pencil in such a weird way. I don't know why, but okay. Let's just hold it normally. Cos of B plus sine of B multiplied by cos of, I believe, A. All over cos of A multiplied by cos of B. Subtract sine of A, sine of B, right? And we'll start multiplying it by numbers, okay? So let's see what we can do. Okay, we'll first multiply by cos of A, right? We'll do 1 over cos of A over 1 over cos of A. As you guys know, this is equal to 1, so, and let's do it. And as you can see, this part right here would become tan of A multiplied by cos of B plus sine of B, because this part will become a 1, right? And this bottom part, this becomes a 1. So then it's 1 multiplied by cos of B subtracted by sine of A multiplied by actually no, tan of A multiplied by sine of B, right? Okay, so now let's rewrite that thing. So we have tan of A plus sine of B all over cos of cos of B, I believe, subtracted by tan of A times sine of B. Okay, so let's do another thing. We'll just divide it. We'll multiply it again by 1 over cos of B. And with this, actually, I don't think I have to explain this. I'm pretty sure you guys can all do this. If you guys know how to simplify trig identities and expand them and stuff, I'm pretty sure you guys can all do this on your own. But I'll explain it anyways, because why not? So, sine of B over cos of B becomes tan of B. Cos of B divided by cos of B becomes 1. We'll actually label this as tan of B. And we'll label this as 1. And sine of B over cos of B becomes tan of B, and this becomes tan of A multiplied by tan of B. Okay, perfect. Now let's write down our final equation, and that is equal to tan of A plus tan of B over 1 subtract tan of A times tan of B. Okay, so this part, I'm not very sure if it's correct, so because I never really checked on this one. I was just messing around on the blackboard and okay, whatever. Okay, so let's just experiment. We'll do 45, right? So as we know, tan of 45 plus 45 is infinite. So we'll look at tan of 45 plus 45. And that becomes tan of 45 plus tan of 45 over 1 subtract tan of 45 multiplied by tan of 45. Okay, so tan of 45 becomes, I believe, 1, right? So we have 1 times 1, and we have 2. So this is a 1, this is a 1, and this is a 1. So we have 2 over 1 subtract 1, which is 2 over 0, which we can pretty much call infinity, right? We'll use, if we use limiters, then this approaches infinity, right? Okay, so we have the trig stuff out of the way, which is good. Now we can start doing the more fun parts, like logarithms and such. Okay, so what we'll start off with is, should we do logarithms or should we do e to the x? Okay. Okay, so we'll do logarithms, okay? We'll do, hope you guys can see that. Let's see. Okay. Okay, so we have ln of a plus b, and by the rule of logs, this is equal to actually ln times a of b, not plus, ln of a plus ln of b. And you guys might be like, why is that the case? Well, we're gonna see right now, right? Okay, so let's see what this is equal to when we get rid of this fancy ln. So as we know, ln is e to the power of some number equals another number, right? So we can say ln, e to the power of x equals a, and e to the power of d is equal to b, okay? We'll say that, right? And by this definition, that means ln of a must be equal to x, and ln of b must be equal to d, correct? Yeah, okay. So what we'll now do is we'll pretty much add both of the numbers, okay? So we'll do a plus b, right? Which is equal to e to the x plus e to the d. Actually, we'll multiply it. I don't know why I added it right there. Actually, like brain dead. Okay, hold on. Okay, so we'll do e to the x times e to the d, which is equal to a times b, I believe, yeah. And we'll take the ln of both of the sides. Okay, and let's simplify this part right here. So we have ln of e to the x plus d must be equal to ln of a times b. Okay, let's not mess around with this side right here, because this is the answer we want to get. Oh my god, why am I so bad with writing? Okay, this is the answer we want to get, so we'll just leave this side alone. And we'll look at this part. Okay, so as you guys know, probably know, ln of e to like any power, so e to like x, will always equal x. And why that's the case is because this right here states that ln is e, so e to the power of a number we'll call n, so this is our number, must be equal to e to the x, right? That's what ln means, right? And to make this true, n must always equal x, right? Can you guys see that? Yeah, you guys can. Okay, that's good. Okay, so now that we have got that out of the way, we can say that x plus d must be equal to ln of a times b, right? And what we can now do is, well, what did we say that a x and d was equal to? Well, we said that that's equal to ln of a plus ln of d, I believe, must be equal to ln of a times b. ln of b, I don't know why I wrote the d. Okay, yeah. Okay, so we have that out of the way. So now let's look at something else. Let's look at ln of a to the power of b, to the power of b. And by the rule that this states that must be equal to b multiplied by ln of a. Okay, so let's see why that's the case. Okay, so we'll look at what a is equal to, right? So what ln of a would be equal to. ln of a would be equal to e to the power of x equals a. Okay, so let's take the power. So we'll take it to the power of b on both sides, right? And we'll take the ln of both sides, right? Actually, yeah. So this should work. Okay, we'll take ln of e to the x times b, because x to the power of, okay, so if I have e to the x bracket to the power of b, that literally just means e to the x times b, right? And why, you might ask, is if we have e to the x to the power of, like, let's say 2, this means we have e to the x times e to the x. In other words, this simply means you do e to the x multiplied by 2, right? I don't even know if that's like a clear, like, I don't even know if I need to explain this because it's quite simple, so let's leave it to that or whatever. If you guys just mess around on paper, you guys will be able to figure it out. So this is equal to a to the power of b, right? Okay, so this means that x times b, did we say b? Yeah, x times b must be equal to a to the power of b. So ln of a to the power of b, ln of a to the power of b. Okay, so ln of a to the power of b. Okay, so what is x equal to? Well, we said that x was equal to, well, we didn't say it actually, but if we say that e to the x must equal a, then x must equal ln of a, correct? Yeah, so that means ln of a times b must be equal to ln of a to the power of b. There we go. And we just explained it. Okay. Now let's take a few derivatives, and I'm probably going to stop after this. But yeah. Wait, can you see that? Yeah, you can. Okay, lucky. Okay. So we'll do that. Okay, let's just take the d over dx of, you know what? ln of x. This one's quite fun to do. Okay, so by the definition of derivatives, this means that this is equal to ln of x plus n subtracted by the ln of x all over n. Hold on, I might have to sneeze. Okay, great. Okay, so that's what we have, and we also must introduce a limit of n as that goes to 0. Okay, so we have this thing over here, and we already covered that ln of, so if I have ln of a number, so ln of x subtract ln of b, this is the same as having ln of x divided by b, right? Because if ln of x plus ln of b is equal to ln of x times b, then the opposite is division, right? Yeah. So we'll just say that. So we have ln of x plus n over x times 1n. You know, I'm gonna stop writing this limit thing. I'll just draw this line, okay? So okay, so let's look at this, right? When we have ln of this times 1 over n, this is the same as taking the ln, as we learned before, of x plus n over x to the power of 1 over n, right? Yeah, so what we'll now do is we'll come back to this problem right here, okay? So let's just put like a box around it or something, okay? So as we know that e is equal to 1 plus 1 over n to the power of n as n goes to infinity. So that would mean that this part would approach 0. Okay, and let's do a u substitution. So we'll do u is equal to 1 over n. This means that as 1 plus u over 1 over u, as u approaches now 0, this part would equal e. So before this n needed to approach infinity, but now u just needs to approach to 0, right? Yeah, okay, so now we'll start playing around with this. Okay, so we have ln of 1 plus n over x raised to the power of 1n must be equal to, you know, whatever, right? So this is our derivative of e to the of ln of x, right? So what we'll now do is we'll look at e, right? We'll look at e. Wow, that's really helpful. We'll do a u substitution here, okay? So we'll say that u is equal to n over x, okay? So now the limit will actually change over here, right? Actually, it'll change over here, okay? So now we have ln of 1 plus u raised to the power of, if I say u is equal to 1 over x, that means 1 over n over x, n over x, is equal to x over n. That means we have to multiply this by 1 over x, right? So is equal to ln of 1 plus u to the power of u, 1 over u times 1 over x, right? And we have to calculate the natural log of this thing over here, okay? So what we can now do is, when I take the derivative, when I take the power, when I multiply the power, it's the same as saying if I take the ln of 1 plus u, right, to the 1 over u to the power of 1 over x, okay? There's no difference, okay? They would still multiply, okay? And right here, let's actually just explain that the limit of u approaches 0, right? And you might be asking why. Well, look, if n approaches 0, then n over x must also approach 0. Therefore, u must also approach 0. Okay, yeah, you guys can see that. That's good. Okay, so let's start. Let's just, okay, I thought I had to burp, but okay. So as we know, the ln, the log of like a to the power of b is equal to b times the log of a, right? So we'll just move this. Oh my god. We'll just, what? Okay, we'll move that over there. So we have 1 over x of ln of 1 plus u raised to the 1u, okay? Okay, now here's where the fun parts come in. Look at this right here. If u goes to 0, then this equation must go to e. So we can say now that we have 1 over x of times ln of e. Okay? And as we know, that ln of e must be equal to 1. So this part now becomes 1 over x. So we can now say that confidently that the derivative of ln of x must be equal to 1 over x. Okay? And there you go. That's where your first thing came from. Okay, now let's do another one where we use, do we use u substitution? I don't know if we use u substitution, but let's just see if we can do it for fun, right? So we'll take this one is going to be a little bit shorter, d over dx of 2 to the power of x, okay? So we'll say that a function of x is equal to 2 to the power of x, and we'll take the derivative. Actually, no, before we take the derivative, let's just take the natural log of both sides. Okay, so now we have g, so we just introduced another function of f of x must be equal to the ln of 2 of x, okay? And now we're going to try to take the derivative of both the sides. Okay, as you guys know, the derivative, d over dx of f of x times, no, what did I just do? The d over dx of